Just like we integrated secant, we are going to integrate cosecant x dx. So we're going to let u equal to cosecant x, the original function, see what happens. So we'll have du is equal to cosecant x cotangent x. Remember how we tried last time to make it in terms of sine and cosine, but then we couldn't find sine inside the function, so we're going to try it this way. Oh, by the way, this is negative, so we are integrating now. We're going to leave the cosecant from the original function, and we're going to multiply by a factor of 1. Our factor of 1 is going to come from this new term, the cotangent and the negative that we have here. So we're going to do negative cotangent x and negative cotangent x dx, and this is going to be equal to, now right now if I were to do a u substitution, I usually choose the denominator. So if I let u equal to negative cotangent x right now, I'll have a derivative that's negative cosecant squared x dx, which would have been a positive cosecant squared x dx. And I don't have that term represented in the function, so like I did with the original one, I have to re-choose or reevaluate this factor of 1. So I'm reevaluating the factor of 1, so I'm going to have cosecant x times negative cotangent. I'm going to keep that the same, but now I need a factor of cosecant squared, so I'm going to add cosecant, because if I multiplied these two, I would get the cosecant squared divided by negative cotangent plus cosecant x dx. Alright, now let's revisit this with a u substitution, our new u substitution. Let's try u is equal to the negative cotangent plus cosecant x. So then du would equal to a negative of a negative cosecant squared x plus a negative cosecant x cotangent x. And all of this gets the dx. So now if I rewrite this, I'll have du is equal to cosecant squared x minus cosecant x cotangent x dx. Alright, let's see if I rewrite that, if that turns into anything, an easier way to look at the function. So if I integrate cosecant x times the quantity of negative cotangent x plus cosecant x all over negative cotangent x plus cosecant x. Alright, so right now we have that this bottom piece is our u, and if I look at the top and if I were to factor it out, I'd get a negative cosecant x cotangent x and a positive cosecant squared x, which looks exactly the same as this. I have a positive cosecant squared and a negative cosecant x cotangent x. So this whole expression again is our du. So I have du. I don't have anything left in the numerator, I just have a factor of 1, so I'm going to have 1 over the integral of, I'm going to integrate 1 over u du, which would be equal to ln absolute value of u plus c. So in this case, our function is equal to ln absolute value of negative cotangent x plus cosecant x plus c. And that will work for any domain as long as the domains match. So make sure when you're using this formula that the domain here in the beginning matches the domain here at the end. Alright, I'll show you some more examples in a following video.